Now we are going to move on to the next speaker, who is Carolina Bianchini Mattison. Carolina used to work at CERN in the BIMS department. She's a computer engineer who also holds a master's degree on industrial automation. And she's currently working at the SLAC National Accelerator Laboratory in the US. So Carolina, I'm sure she's going to give us more details.
Thank you, Maria, for the introduction. So as Maria said, I graduated from Rome, Italy in 2014 for industrial automation, and I have a background as computer science. Given the degree, my skill set was focused on programming, so Python, C, C++, and Java. And by working at SLAC, I became an expert of ABIX, which is a different type of control system than what is used at CERN. And during my work experience, I have developed like presentation and communication skills through the different opportunities and learn how to target the presentations and the complex topics to different target of audience as well. So my professional experience started at INFN. I started actually when I was in high school as like summer programs there. INFN is like a smaller scale version of CERN if you want, but it's in Italy, and they have different labs in the different connected with the different universities. So that's why it's kind of special, because each university has its own small lab there. So I did my bachelor degree program with INFN, and then I did also the master degree project through INFN and CERN. So by working at INFN, I learned about the opportunity for CERN, and that's when I asked to freeze my current contract at INFN and move to CERN. And then I came back and worked for INFN while I was getting all the paperwork to move on and work at SLAC, which obviously was a different transition because I left Europe and there was a lot of more paperwork involved with that. So my experience at INFN, it was with the physicists and engineers that worked on ATLAS for the drift chambers. The drift chambers are a type of detector that is used for measuring the beam profile and the energy value of different particles. This was around the time where we found the Higgs boson. I remember it was like day 4 when this was discovered, and it was like a great experience to be there for it. During my internship there, I had a test bench for the drift chambers, and I learned how to code from C, that it was like an academic skill applied to C root, which is slightly different, right? And here I learned how to do, for the first time out of academia, the analysis of signal quality and study the consistent behavior between the different chambers. And I was able to define correlation effects and really learn how to analyze data that before I didn't have to like start from scratch with analyzing, and it was a different experience. So what skills did I acquire with this? It was the deeper knowledge of C through C root, and learning how to do data analysis, recognize correlation effect, and determine a correction function, which is something that they teach you out of the book in school, but it's different when you're actually applying into your job. And this was my first solid experience in the research environment. Then I moved to Switzerland and France at CERN, and here I did a technical student. During the technical student project, I worked on the wire scanners. The wire scanners are devices that are used for determining the beam profile for LHC and all its injectors. During my project here, I studied and select mathematical routines for MATLAB, and then translated that into Python and developed a calibration program in Python. And then as a final product, I provided a GUI to interact with this code. What did I acquire as a skill from this experience? It was like learning how to compare and understand different algorithms. New skills as of expanding my background from C and Java into Python. And then it's like a personal skill that I learned is like learning how to ask questions about what are you expecting from a GUI, who are my stakeholders, who is going to utilize the GUI, and what it should look like, and how to ask the right questions for that. And again, presenting like a complex topic to by understanding the background of the audience that you have in front of you as well. Then I got the opportunity to work at SLAC. I actually got, I applied for SLAC because through CERN, our HR department was sending out the opportunities as our technical students was finishing up. And the job posting for this one was matching my master degree name. And so I got interested and I applied for the job and I got to know them. I came to SLAC to visit and see how, it was only 3 days, but it is important to see where you're gonna move, where is the location of your job, and if you feel like you're gonna fit in there and you're gonna like it. So here I work in the electronic engineering department under the basically we are the engineers that support the machine operation for LCLS, LCLS-II, and FACET, and all the different facilities that we have at SLAC. So when I started, for the first 6 months, I did operation support. During my experience as operation support, I answered and resolved operation tickets for software improvements. And that allowed me to learn about the SLAC control system. As I said, they use ABIX and it was a different word for me. I learned a little bit about different subsystems that are part of our accelerator complex, where there is the vacuum system or the timing system, the machine production system, or the different devices like the wire scanners and so on. This allowed me also to meet a lot of experts and learn how the machine was operating. After that, as a software developer, I focused on one big complex subsystems, and I learned the most about it. So I was paired with the expert at the time that was gonna retire, and we just made the most of knowledge transfer for the time that we had. And here I continue to use all my skills as programming in multiple languages, presenting to a large audience, and write technical specification document, design, and collaborate with other engineers. So I became the timing system expert for LCLS and the other accelerators. And then in 2020, we did one of our big projects, which was while the LCLS-II project was getting finished to be built, we decided to use that dark beam line to receive beam from the copper LINAC from LCLS. And so a lag was installed, and the CLTS project was initiated. And out of this project, it was the first time that I led the timing system as a subsystem lead, and I was able to define some of the specifications and gather the requirements from the different stakeholders, such as physicists, and figure out how to achieve what they wanted to do with the physics as well, given the engineering restrictions that we had. With this, I learned how to coordinate and manage a large team of engineers that is cross-directorate. So it's not just in my division, but in other division. So they have different managers and they have different practices, and try to like be responsible of what is actually getting delivered to operation. I've had 2 publications, one in 2017, where the first design of the LCLS-II timing pattern generator configuration GUI came out. And I also presented the LCLS machine production system high-level interface improvements. And then I co-author in 2020 the dual energy for LCLS and the copper LINAC. These are my contact information if anybody wanted to reach out later.